Okay, let's talk about annuities where the payment period is a small, the less frequent payment, number of payments are less frequent than how many time interest are calculated. So let me draw a timeline and explain what this means. So you can have 0, then the payment after K interest payment period. Like let's say you are calculating interest based on every quarter. Then if you get payment at every end of year, that means then the interest calculate every 4 times per year, but the payment is only once per year. Okay, so for example, interest is calculated at the end of each quarter, and the payment only once per year. Okay, so in this case, you can say, okay, interest is calculated every end of every quarter. So you have 1, 2, 3, 4, and then the payment is here. So all of this is where you get the interest. Okay, but payment is only once. So payment is less frequent than interest is convertible. Another example would be interest is credited every 6 months. Payment only at the end of year. So in that case, if I draw the timeline, every 6 months. So this is 6 months, this is 6 months, so you get the interest, but the payment is only at the end of the year. Okay, so this is 0.5, 1, 1.52. So interest is calculated every 6 months, but the payments are only at the end of the year. So payment is less frequent than the interest is convertible. So we are going to discuss this kind of problem. So let's assume interest is calculated K time per payment period. Okay, so in this case, it's 4 times. Okay, it's for if you are calculating interest every quarterly, it's 4 times before you get the payment. In this one, it's 2. So K become either 4 or 2, depending on those two problems. So then the payment, assume there are R payments. Okay, so K is how many times interest is calculated per payment period, and R is total number of payments. So if I draw the timeline, and now it will be look like this. Here you get payment. The K mean basically you get your interest is calculated K time per that payment period. Then here is 2K, the second payment. Here is 3K, third payment. And then here you have RK, the final payment. We are assuming the payment size is level. Okay, so basically level payment. And anyway, this is right away you observe this is annuity immediate. We can do the same setup for the annuity due later. Okay. So now we need to know the rate. So let's assume I. Okay, so assume I is the effective rate for one interest period. Okay. So that means, so K mean, so in the timeline I said this, there are K interest payment periods. So that means you have this small K. Okay, you are dividing this timeline to K period, and then in one of these small one, the rate is I. Okay. So the next one, effective rate is I. Okay, so forth. So then let's calculate capital I, which is effective rate for entire interest, K interest payment period. Okay, so capital I is the effective rate for K interest period. Okay, that means basically this entire time. That's I. Okay, this entire time period I. In here you have this small K. In that one is simple I. Okay. Okay, so how do you get the capital I? You can see right away 1 plus I to the K is basically 1 plus capital I. So from here you can see I is 1 plus I to K minus 1. Okay. So now you can see that if you use this capital I and this P and the other numbers in calculator, you can get the answer. So basically, you can say what? You can say if you want to get, let's say you want to get the future value. Okay. You can enter N is, there are R payments. So you can say N is R. And then the rate, this is the one you need to really be careful. You can enter capital I. And then you can say compounding per year is 1, payment per year is 1. Because you are thinking now this K interest period as 1 year. Okay. So here, let me use with I, yeah, timeline look like, how does it look like? Then it's look like 0, 1, 2, and then for the entire time period, you have the rate I. So it's look like effective rate. This entire time period, you have rate I. So payment per year is 1 now. Compounding per year is 1 because you have the effective rate, okay, for entire time period. Now, and then let me write the rest. The payment is P and percent value is 0. Okay, so you can use your calculator. Now, there's another approach. If you really want to use, if you really don't want to use I, what you can do, you can write the same way. There are R payment, but the compounding per year is basically, it would be K. I mean, the rate would be, you have to take the 4 time, the K time I, and then you have to say compounding per year is K, payment per year is 1. Okay. So this is the other way, because you can see if I use the second one, this second approach, what would the timeline look like? So here I have 0, here 1. And then I have this small, it divided to K. Okay, so this is K. So this is basically rate I. Okay. So then for this one, nominal rate is what? Not effective. Effective is capital I. But nominal is going to be how many interest payment period you have, they are K, and then what's the rate per small period, which is I. Okay. So that's basically what we call as I over Y. Okay. And then how many times compound? You are compounding K time per that time period now. So compounding per year is K. And the payment is only once at the end of the time period. So payment per year is 1. Okay, that's why you have this this setup. The rest is same. Okay, payment is P, present value is 0. Okay. So you have really two approach if you, the way you want to, either you can calculate the effective rate for entire time period, which is capital I, using this formula, or you can go with this second approach, but then you have to enter nominal rate as K time I. So whatever the rate given as per interest period, you have to multiply by how many times you are compounding, then that give you the nominal rate. Again, it's nominal rate, and then change the compounding per year to K, and then payment per year to 1. If you go with the first approach, then compounding per year is going to be 1 because you have effective rate, payment per year is 1, and the rate is capital I, which is effective. This is effective. Okay, so in this section, we analyze annuities where the compounding frequency is larger than payment frequency. So that's what we discussed so far. Okay, so let's derive some formula. So here, first one would be let K be number of interest conversion period in one payment period. Okay, so how many time you are dividing one payment period? Okay, the payment is only once, but you divide it to K time period. Then R be the number of payments. So you have R of this. We divide this in time, small interest calculation period. So let I denote the effective interest rate for the interest period. So for this small time period, rate is I. For this small time period, rate is I. Then the payment period has effective interest rate. The payment period, okay, has effective rate. So for the entire one, you have rate I. For entire one, you have rate I. And we just calculate, we learned about this one. The formula is going to be 1 plus I equal basically 1 plus I to the K. So this is basically 1 plus capital I equal 1 plus simple I to K. Okay. Then the present value of annuity immediate is ANI. Okay, so you can see, because if you know the effective rate, then the present value at time 0 is going to be AN capital I. Okay, not simple I, because now I'm using effective rate. Okay. Basically, I have to discount this to time 0, and the rate I'm going to use is capital I. So my V is going to be 1 over 1 plus capital I. Okay. The present value of annuity lasting n interest period and paying 1 at the end of each K interest period is ANI over SKI. So how do you get that? So you know that you have R payments, okay? And then it says it's lasting n interest period. Okay. So let's see how to do this. So lasting n interest period and paying 1 at the end of each K interest period. Okay. So what this means, basically this means R is going to be N over K. Okay. Or you can say R times K equal N. Okay. So what is R? R is basically number of payments. Okay. So we can calculate the present value, which is AR based on effective rate RI, which is going to be, what is the formula? 1 minus V to the R over I. What is V? V is 1 plus capital I to negative 1. So 1 minus 1 plus capital I to the negative R over capital I. Okay, actually I should have said this capital I. Okay. So then I know the formula for 1 plus I, and we know that 1 plus I is what? 1 plus simple I to K. So I can substitute that here. And then what is I? I is 1 plus I to the K minus 1. Okay. So now let me simplify this a little bit. Not plus minus. Let me divide numerator and denominator both by rate simple I. This one divided by simple I, and then also same for the denominator. But the top one, then that become what? That's become ANI, if you look at the formula. Okay. Why N? Because RK is N, okay. This is N. Remember in here we say RK is N. Okay, so, and then the low one become the future value, okay, SKI. Okay. So that's how you get this first formula. Now, so present value become ANI over SKI. Okay. Now, what's the future value? Future value is going to be present value time 1 plus I to the n, or you can say 1 plus I to the n. So that's going to be what? So if I multiply future value, present value is ANI over SKI time 1 plus I to the n. So if you take the ANI time 1 plus I to the n, that's become what? SNI now. So you can say SNI over SKI. So that's the second formula. Yes, these are good with mathematical wise, but really when you're doing solving problem, you use your calculator. You don't really use this formula that much. Because remember that in here I mentioned you can use a calculator right away using one of these two approaches. Okay. But still knowing the mathematical formula sometimes useful because you may get problem with symbolic answers. So then you need to know which one is correct. Okay, so now we go to the annuity due. The same setup, but at the beginning of time period. So you have 0 here pay. Then after K interest payment period, you get the next one. Then after another K time interest period, you get next one, so forth. So this would be R minus K, the last payment. Not 2 just period. Then here is RP. Again, so these are divided to smaller K time period. Okay, so this is I, which is interest, effective interest rate um, for interest payment period. And this is payment period. That would be capital I. So again, the same setup, 1 plus I equal 1 plus I to the K. Okay, so what is I? I is effective rate per payment period. Okay. Simple I is effective rate per interest payment period. Capital I is effective rate per payment period. Okay, so it's a difference. Then the present value of annuity media is A double dot NI. So what is N? N is RK. There are this is not R. Okay, this is not N. This is R. Yeah. So N is RK, and then the effective rate is present value is going to be A double dot RI. Okay, so you have R payments, and you are using I as effective rate. Then it look like any annuity we learned earlier. So it's going to be A double dot RI. Okay. So suppose K divide N, then you have N equal RK. R is going to be N over K. Okay. You can start from this equation like earlier. One plus I to the 1 plus I to the negative R over D. Okay. You have to be careful with D because uh, because D is discount rate. Okay. So you have to be careful with that one. So instead of going this way, you can use the other approach. We know that the connection between annuity mean and annuity due. We know that a double dot Ri is what? It's going to be 1 plus I to ARI. Okay. This connection we mentioned very early. Let me go and see whether you can find that slide. Very early, like in here. Maybe not in there. Yes. So here you can see the connection, but it's for a perpetuity, but the same formula is. So here, we can use this connection to get the answer. So let me go back. So yeah, in here. Yeah, okay. So I can use that formula. I can write that formula. So then 1 plus I is what? 1 plus I is basically 1 plus simple I to K. ARI is, we just prove that that's going to be what? ANI over SKI. Okay. Um, so so instead of 1 plus IK, I can write it as 1 over 1 plus I to the negative K. So this is basically uh, VK. Okay, this part is VK. And when you discount future value, this is future value, your discount, you get present value. So you get okay. That's how you get this formula. You can multiply it by 1 plus I to the n to get the future value, and then you will get the next formula. Okay. So S double dot Ri is what? 1 plus I to the 1 plus I to the n time present value, which is 1 plus I to the n I over AKI. And these two, when you multiply, you will get what? SNI over AKI. Okay, that's the next one. Okay, so we prove all the formulas. Let's go and do some problems. So here it says Mark is present at an annuity that is to pay 4,000 at the end of each 6 month for 6 years. Okay, so at the end of each 6 month for 6 years, using compound interest at nominal monthly interest rate of 3%, what is the value of Mark reward at the time of the announcement? Okay, so for 6 years, how many payments are we going to get? We are going to get 36, no? This is like the how many payments. Then in here, you are going to credit the rate, nominal monthly rate of 3%. Okay, so then what's the effective rate per month? So if I use the second approach, which I mentioned earlier, I would write I over Y is 3%, but then compounding per year is 12. Payment per year is 2. Okay. Because now I would get 2 payments per year every 6 months. The rate is 3%. It's nominal rate. Compounding is 12 time per year. Okay. Then you can write how many payments you are going to get. How many payments? 36. And future value is 0. Present value what you want. and the payment is going to be 4,000. Okay. So you can see right away that you really don't need the formulas we prove. We can use calculator for the problem. And remember, you are allowed to use this calculator during the exam. So let me reset this calculator. Okay, so we enter 36 for N. Rate is 3%. Then I have to enter payment per year is 2. Compounding per year is 12. Then quit. I have the 0 for future value. 4,000 for payment. And then complete present value. So we see it's 110,169. Let's do this one. Find the present value at the accumulated value of and the accumulated value of the annuity immediate with payment. Annuity immediate with payment 1,500 every 4 years from year 4 to 40. Okay, so you have 0. So the first payment. So this means basically 4 years. Okay. Let me write 4. 8 is 1,500. 40, 1,500. So how many payments we are really going to get? Since it's every 4 years, it's going to be 10 now. Total number of payments is going to be 10. And the payment size is going to be 1,500. The rate is, now this one you can think this as more like 4 times per year. Okay, so your year is actually 4 real years. Okay. So 1 year, your hypothetical 1 year is actually 4 real years. So you are thinking like interest is compound 4 times for that year. Okay, so you can say compounding per year is 8% times 4. I mean the rate is 8% times 4, but compounding per year is 4 times. Then the payment per year is 1. Okay, so what that means, basically you are thinking like this. So 0, 1, 2, 3, 4. So here you get the first payment. For each time period, your rate is 8%. Then the nominal rate for this entire time period is 8% times 4. Okay, what is this? Nominal. Okay, not effective. Nominal. Okay. That's why I put 8% times 4. Then the compounding per year, then in here, year mean actually our hypothetical year. This is actually 4 years. Okay. Is 4 times. And the payment for that hypothetical year is only once because you are getting only 1. Okay, so now you can enter the present value to be what you want. Set the future value 0. Okay, when you're finding present value, you set the future value to 0. So let's use our calculator and get the answer. Okay, so 10 for N, 1,500 for payment, 0 for future value. Rate is 32%. And then second payment per year is 1, but compounding per year is 4. And then second quit. And then I need what? I need present value. 3,069. You can calculate the future values too. In that setup, you set the present value to 0 and you calculate the future value. I will leave that for you to do. Here is another problem. An annuity pays 1,000 at time 0, time 3, time 6 until 20 payments have been made. Calculate the present value and the current value using an annual effective rate of 6%. So here is 0, 3, 6 until 20 payments. So 20 payments mean what? So every 3, that means 60. No? Annual effective rate of 6%. So that means for given time, like if you divide this on the 3 time slot, per period it's 6%. Okay. Per time, effective time period. So this one is 6%. This one is 6%. Okay. So we can use the compounding per year. So we can define year as 3 time unit. Okay. So then we have how many payments? We have 20. Compounding per year, it's going to be 3 times, no? Because each year consists 3 time unit. Payment per year is once, because at the end of the 3 time unit, you get 1 payment. And the rate is, the nominal rate is that per unit is 6% per time unit. So you have 3, so you multiply by 3. That's the nominal rate. Then the present value, if you want that, you leave it there. Payment is going to be 1,000, and future value you need to set 0 if you want the present value. Okay. If you are calculating future value, you set present value to 0 and you calculate future value. Okay. Let's use our calculator. Okay, second reset. 24N, 18 for red, but then I have to set the payment per year is 1, compounding per year is 3. Then the payment amount is 1,000, 0 for future value, complete present value, 5,076. So you can see that these problems are not really that hard. So I will leave this problem for you to do. Try it and see what you get. Okay, so we will meet again for next topic.